Okay, folks, let me start up Zoom here. How's everyone doing? The darkest timeline is true. I didn't do anything. I wanted the Chiefs to win. I'm not a Niner gang fan. From LA, can't be both, respectively.
They're a division rival. Maybe they have to beat them.
They're a division rival for who? Oh, I don't like the Chargers though. That's fair. I get it. I understand. Anything else fun happen? How did people feel about the homework? Did you know that it was due? I saw some stuff being trickling in. This is again my first warning, right? And what I mean by that is not like a specific warning against you, but you may think to yourself, well, I'll just let it, lower priority. And that's fine, right? There is some flexibility associated with taking a class where you're constantly going back and you're updating. And I'm also noticing this in the pair programming, right? If you never go back to the pair programming and finish it, then you really are not going to have the tools to do the homework. So even if we don't finish it in class, right? Like I was here for office hours and I didn't see a single soul, and I don't mind about for me, right? Because I sit here and I do my own work. But for you, it's a wasted opportunity to really make sure that you are not missing out on any information that you need in order to do well in the class. Now, I do get it that that's during lunch. So if that time doesn't work for folks, just let me know and we'll change it, right? Because if I get people not coming to office hours every single week, then I don't know what else to do, right? There's no other time for me to talk to you. So for the most part, the first homework is always just like, okay, can I do the required work in the required amount of time? I know how much time I'm supposed to be committing to this class. We have a lot of time in lab. We can kind of walk through those things as well. And maybe you find yourself at the end of lab, you're like, hey, can I ask you 3 questions about the homework? I would strongly encourage you to always look at the homeworks first, right? Monday or Tuesday before they're due. So you'll have another homework. Oh no, not another one. And you'll see that it's 3.3 and 3.4. So fewer problems, right? And it'll be sort of this stuff that we're going to be learning on Wednesday and a little bit of what Zuri is going to talk about today. And these problems here, one of them is a graphics problem. One of them is about your computer. So you'll notice that sometimes it's only 1 problem. Sometimes it's 2. Maybe this was too many problems at first. You can tell me. Yeah, but you had 3 weeks to do it. So we want to make sure that, however you're approaching this class, right? Whether you're thinking, okay, I'm going to do the homework every week, or if you're just going to do it on Wednesdays, you got to be disciplined about it, right? You got to make sure that you're staying on top of yourself, because I can only give you so much crack of the whip, right? I can't sit inside your room and be like, you should really be working on this for another hour. And if you're having troubles, reach out to me on Slack or come to my office hours or send me an email, right? If I don't hear from any of you, I'll assume you're all doing great. And then when I see you're playing pair programming and it's not all complete, I'll be like, where's the disconnect here, right? And especially with homework. If everyone's late on homework, I'll be like, oh, maybe we should make this a strict deadline, right? So that flexibility is something that we'll have to sort of work with. Okay, 2, 4, 6. Okay. Ready? Okay. Any questions before we get started? Okay, so let's do. And everyone has chapter 3 too. I think that's also part of the sample chapters that still exist. Anyone not have the book or found a version of the book? Cool. Okay.
So far, we have been creating programs to print out words and numbers, but sometimes if we want to create pictures of some sort, we have to program produce graphics. So there are 2 types of computer graphics used in physics. The first one is graphs, and Python has numbers of features for making graphs, but it's specifically focusing on easy to use package called PHYS. This package can generate many different types of graphs, but with only talks about the main kind, which is the ordinary graphs, scatter plots, and density of plots. So for the ordinary graphs, the function we use is called plot from the PYLab package. The function takes a list of arrays we want to plot and creates a graph of the given values. Here, so we see here that we have 5 equals the list, then we have plots. So once we plot, the computer retains information, but it won't actually show you the image unless you use the function that's show. That function has no arguments, so nothing doesn't see it. So yeah.
Yeah, and so just to clarify here, right? Because you could theoretically write more things. You could plot Y, you could plot XY, you could plot Z, and then you might want to load all of those in individually, and maybe you want to change the width of Y first and change the title for Z and only show it at the very end, right? And so show just differentiates between when you started talking about this stuff and when it's plotted.
Here, they want to grab the function sine x.
Oh, sorry. Yeah. There you go.
So here they want to grab the function, sine x from x equals 0 to x equals 10. So we use the line space to generate the array of x values and the sine function for a special version of the sine that works with the arrays. So then if we use that,
Okay, so let's break that down for folks who maybe haven't tried this at home. So what does this function do? Sorry. Because you've all been doing the reading, right? Before you come to class. So what does line space do? What does this highlighted function do? Say that again. It generates an array. And what does it populate the array with? X values that go from? Okay. It goes from 0 to 10. How many X values does it generate? Good question. Yeah. What does that mean? That's what I'm asking.
So it's
Yeah.
going from 0 to 10 with increments of 100.
Okay. Increments of 100. What do you mean by that? So does it move in steps of 100?
Sorry, it's being divided 100 times.
Ah, okay, good. So this is exactly what line space does. The first argument says the start. The second argument says the end. And then this says how many bins or how many steps do you want to take? That make sense? And you get an array. Okay, what's the next one do? What's the next line do?
So, right?
Yeah.
It's plotting a sine function on the.
Nope, doesn't plot anything. Next line does not plot anything.
XY graph for the function, whatever is plotted inside that function.
I'm just talking about this line. Don't jump ahead. Don't look at that. Just this line only. Yeah. So, but what is sin x? I know, forget. Okay, that's correct. But what is sin x really? Remember, we are not thinking like mathematicians. We're not thinking like physicists. You are communicating to rocks. So you need to be very careful about your overinterpretation of the words that you see on screen. This first one says, here is an array with values. What does this next line say?
It's saying how to put those values,
Which values?
the X.
The x values. So this is an array. So now apply sign to every value in the array to create a new array. That's what this line says, right? And that's an important difference because you're thinking about this not just as some random, arbitrary, okay, then y is always going to be sine of x. No, this is going to be whatever x was. Remember, that's just specific numbers and apply sign every value in the array and then rename that new array y. You see? Okay, so we'll break the steps down so that they're more manageable. Okay, now let's ask the next line. That's the easy one, right? Anyone can do this one. You're plotting it. Okay, good. Whew. All right, and then does it show up right away? Okay, now we're coding with steam. Okay, or rocks or whatever they're called. All right, go ahead. And there's your curve up.
Values and values, and it puts them in an array. And except, and the array slicing, the settings are in there, under the ground. Extract the first and second column of the array and puts them in a separate array.
Okay, so let's walk through this one because this one's also complicated. So what do we do here? First line. Importing what? Load text. And how would I do this in real life? Would I only import load text? Or would I say import numpy as np? So that way I just have all of it ready to go. Right? Okay, next line. What's it do? Yeah. Good. Okay. All right. Next line is the hardest. So the text file already exists. I'm going to hand it to you. It's called values.txt. Okay. And now what do you do? Or what do you tell the rocks to do? Create a float. Float what? Okay, so this thing is going to read in this file, and it's going to prepare for the value type float, like you said. And what thing is put out here? Yeah, is this arbitrary? Is this some magical pixie dust, or is this a what? Yeah, so a variable, for example, always has a type, right? So it could be a string of characters, it could be an array, it could be a constant, it could be complex. Yeah. If I'm loading this file, values.txt, I'm telling the computer ahead of time, hey, I'm only going to give you floats here. So turn everything into floats. And then this whole command, load txt, is assigned to what? To data, good. And data is a, or an array. Ah, okay, that's meaningful, right? So if it's a list or an array, that means that I can use it, right, in order to plot it and do other things. Okay, so the actual type of object that it is matters. Does that make sense? It's not just arbitrarily, oh, it's called data, right? It's important that it's either a list or an array, because depending on if it's a list or an array, then I can do this type of thing to it, but not this, right? So arrays, for example, can't change the size of. So I couldn't pop an item out and I couldn't append to an array. But if it were in a list, I could do those things, but I wouldn't be able to use certain plotting techniques, right? Okay, so it's important to figure out what the thing is that you're loading. So you get the data, great, wonderful. What's this first line say? I will strongly recommend that you have chapter 2 ready to go, because you're going to have something called slicing in it. Now, slicing sounds really cool, but it's not. So what does slicing mean in an array? Let's say I have a two-dimensional array. Let's call this test. Okay. And test has what sizes? Yeah, another way of saying that would be just 4 by 3. It's a 4 by 3 array. So there's 4 in this direction and 3 in this direction, right? And we do want all of these values. So we're going to go through and it has length, for example, of 12, but the parameters of it are 4 by 2. And so, for example, if you have something like this, which is two-dimensional data, so you just saw there in the type of data we're looking at, that it's two-dimensional data, right? I have 2 columns. It just so happens that one of them is very long, right? It's not square. If I covered up half of this, you might be convinced, oh, okay, that kind of looks similar, right? Okay. So now how do I slice? Yeah. Colon. Very good question. What do they do? When we tell a computer colon inside of parentheses, what are we asking for? So this symbol, here's your list, right? Let's say test colon. What is it telling the computer? Yeah. What kind of slice? What's that? Yeah, so we're going to talk about the orientation of those 2 numbers, but let's just first talk about what the colon says. So the colon, by definition, is the whole thing. As opposed to if I said test 0, what would that mean? Yeah, the very first element, right? We start with 0. So it'd be one element of the whole array. As opposed to colon says the whole array. You see? Okay. So this would be the first element. Okay, now watch this. We're going to do some magic. Test colon 4. Yeah. Right, yeah, so right now, forget that this exists because we're not gonna slice yet, but you're saying go up to 4. So start at 0, 1, 2, 3, and 4. So the first 5 elements. Right? Now let's be more careful. Let's go 2 to 4. I'm not gonna write that one up there. Do you get the picture now? Okay, this is slicing. Okay, so you're grabbing a section of the array. For our 2-dimensional example, you can also orient yourself in both parts there. So for example, you have :0. So where does that exist here? 1, 5, 3. This is :0. What's the next one? What? :1. What's the next one? :2. Okay, I'm not gonna do the last one. What's this one? Very good. There we go. Now we're slicing. Okay. Let's do this one. And you'll notice I excluded 12. :2, so this will be 0, 1, 2. Boom. Right? Whenever you see an empty colon like that, what you really should be thinking, I mean, you don't need to be thinking this, is 0 to the end. And remember we said -1 is the way to jump to the end? Okay. Does that make sense now? Oh, wow. Slicing. So we'll be doing a lot of slicing throughout the rest of this entire semester. You'll be taking arrays. Sometimes you'll have an array, and let's say the array represents like a pool of water. And you have some boundary conditions, like the bottom is hot down here, and everything else is allowed to cool off as it wants to. So you're gonna model on the interior, you're gonna find out how the water moves, and you're gonna keep the sides fixed. So you have an array that shows the heat all the way through, but you never want to update the edges. So you'll need careful slicing in order to figure out how to update only the interior and not the edges, right? Can you figure out what that slicing would be? What's the first row here? What's that? Yeah, what I want the array coordinates for the entire first row. So we actually go :0 is this way. So the first row would be 0. Oops, colon. Right? Good. And then this one? :0. Yeah, I just said that. Okay. :0. And then what if I want just this stuff in here? Yeah, 1. So if I want to start here, that's starting at location 1, right? So I could be like 1. I want the whole thing except for well, notice here I don't want this first one. And this first one is 0. And this is 1.
So we do 1,
1, comma, 1, colon. Because the 1 tells you this first line, right? Not the top one, but the second one. Yeah, I'm asking for this line right here. It's magical imaginary. Okay, 1, colon, 1, comma, 1, colon, and then how do I go 1 away from the edge? -1, and how do I go 2 away from the edge? Ah, right? You see a generalization yet? If you just want the box inside? Okay, what is it? I want every item of the box inside. I want this one. Watch now, I'm not just doing one row, I want all of the dots. Yeah, watch, and I'm gonna get that. So that's all of the values this way, right? From here to -2. And then I want all of the values from here to here. No, because this one is only for the first row. You see? So here I have a range of numbers from 1 to -2. And here I have another range of numbers from 1 to -2. And notice that because there's a range of numbers here and a range of numbers here, this must be a 2D array. Whereas this one is just a list of numbers, right? So just positions like this. So it's like a vector.
Yeah, that's so kind of confusing because if you want all of it, to me, that looks like you're still working on the first row and also the left row too. Doesn't-
So from here, this is 1, and then this is -2. And then this is 1, and this is -2. Does that make sense yet?
Like, for instance, I think, you thought you wanted everything like this, but you just wanted everything, or you just wanted the first row of everything.
So basically the way that you should read this is the upper point here, right? And then this is, wait, hold on, let's do this properly. This is the upper point here. So let's call this x1. And this is x2. Right? And then this is y1. And this is y2. Yeah, so I could write it like this. I could write it like 1, comma. Does that make sense? Yeah. Yeah, so unlike reading, the coordinates off of a graph, you're not gonna have x and y intermingled because in some cases, right, like this would just say, this is y here, and these are your range of x values, x1 to x2, right? So all of the y values in a line, whether that's a straight way across the matrix this way or like that. Is that process making a tiny bit more sense? Anyone more lost than when you started? Okay. All right, ready? Mm-hmm.
It's sort of like if you want to function, and you want to do anything more into YouTube, close the window. You do any kind of closing, then it won't proceed.
So for the Python labs that we'll be using, you won't run into this issue as much because it'll just, spit out the answer and you are already going to work in the next box. Right.
So sometimes you don't,
Okay, go ahead. Sorry.
sometimes you don't know all of the X and Y values for a graph. In this case, a good way to create a graph of the result is to start with two empty lists of the X and Y coordinates and voice them as you. Here, you notice how we created the two empty lists and then append values to the end of each one of these.
Does this process make sense? Anyone confused by this?
So what is it saying that like if you're creating two empty X and Y like points,
Mm-hmm.
does that mean you can append like whatever values you want back into those and that would become your new X's and Y's?
Yeah, so X points, right, doesn't know anything about X. It shares the letter, but they're completely disrelated, right? So this thing here is what is iterating. So this is going from 0 to 0.1 to 0.2 to 0.3 to 0.4. It's taking on all of the values in this array because we already said that line space is an array. And so the for loop here says use X and assume every variable in this list or array, right? Start at the beginning and go to the end of the list. And then inside of that loop, append the value of X into X points and append sign of that value into Y points. Does that make sense?
So we have the empty lists, are they like just assign like a zero value to them, or are they completely undefined until you?
Yes. They are undefined. That's the right way to think about them. They're not zeros because otherwise we'd use zeros. And that's the interesting part too. We'll get to this when we think about sort of larger calculations, whether to use an array that has zeros or an array that uses empties. We haven't talked about what empty is, but it's basically whatever was left over. So 0 is a finite number. The absence of a number is a weird thing to think about because you think in your head that that means 0, but really it's whatever the computer was storing at the time there. Does that make sense? Could be gobbledygook, but it could be a number. And we'll talk about why that can introduce errors when we get into chapter 4. Okay.
So there are some add to the graph. So if you don't want the curve to touch the very top and the bottom of the frame, if you want more space between them, you can use a frame and hide them. Here, they put a Y link and then Y. And if you run it, you should be able to see the space between the curve and the Y axis. Notice how Y limit is after the plus statement, but before the show statement, that's because the plus statement has to be created. Has to create the graph first.
Yeah, so this is a really important point that Zur is pointing out, is that the plot creates a real thing, right? So just like we create some array that has values that we put inside of it, until you create the thing called plot, you can't make any modifications to it. Sensible? And then we're talking to rocks, right? Okay. Oh, this came out really well online. Yeah, you can barely see them here, but it's not quite going to 1 anymore, right? Okay.
See that now. So, so this is the style we want to do. You do that by adding a third argument to the function. So KO, so the letters that are the color. So R is red, green, sign, and that's yellow, black. And then the letter after, so the dash is a solid line. So that 2 dashes is a fixed line, and a couple is marked points of circles, and then because S is overhead or square.
Yeah.
See that.
So you'll notice right here, right? These are the dots, and then these are the dashes. And there's lots more options. You can go online, and we'll be using, you can probably start with PyLab, but we'll eventually go to Matplotlib, and the colors are endless. Like I like to use, color equals Dodger blue for reasons, okay? And you'll see that they have a whole variety of named colors. You can use crosses for your symbols. You can use, fancy stars, 4-pointed stars, right? Okay. So you have your sine and cosine. Let's stay off of 3.2. Let's try to use 3.1 first. I believe the problem that we have for today, hold on, is 3.3. Oh God, where'd it go? Oh, jeez. It's 3.1, right? So that is right here. And that has plotting experimental data. Yay! So we're gonna have to do a lot of fun things today. We're gonna have to learn how to download data, and then we're gonna upload it into CoCalc. Now you think to yourself, oh, this is gonna take a really long time. No, it'll be very fast. But when you do it wrong, because everyone does it wrong the first time, it'll be annoying, okay? So the first thing you're gonna do is you're gonna go to the online resources, and you'll find it here, you see? And you can type that in, or you can copy and paste that from your own book. And you'll see CP resources. So you're looking for a file called sunspots.txt. And what you'll need to do is, for pair programming this week, you'll need to take that file that you downloaded off the internet, text file, and upload it into the location that your file that you're working on in CoCalc is. Because your CoCalc, let's say your pair programming of the day, is going to exist in a folder called pair programming, probably, I hope, right? And if you don't have any other subfolders, if everything that you're working on is in that one folder, then you just add that into the same folder. And you'll see when you open up your pair programming, you'll have an opportunity to upload. It'll look like a little plus. You can click the plus, and you can select the file from where you downloaded it, probably in your downloads, right? And then CoCalc will know where that is. So it'll look for a file called Sunspots, and using this wonderful where is it? There we go. Okay, so using something maybe similar to this, you may find that you can download a text file, open it, assign it values of float, and then plot it. Okay, so this is going to feel a little different than the last couple of weeks I've felt, where we're doing for loops and if loops. Okay, we're going to be slicing them. So as you begin to start looking at this array, right, really think of it in the context of it is a physical thing that has a finite size in either direction. And you're working out how to grab sections of it and display them. Because of course, science is a communication. So if we have this really great data and you hand it to someone in the form of a table, they will scream, right? They want to see what it looks like, right? Okay. So select your friend for the week. Ideally, someone you haven't worked with before. There's an 11, so we'll need one group of 3 if that's okay. And that's all we're going to try today. We're just going to try to do 3.1. Okay. And if we want to go back to any of your previous homeworks, I think we may have probably like 30 minutes to 45 minutes at the end, depending on how strenuous this is for folks. Yeah. What?
For the, we were pulling that zip file, right? That's where the